program is designed for pupils in primary, junior, and senior schools in order to facilitate the learning of mathematics in our schools. It will help you to recall concepts in mathematics that you have already learned so as to enhance your understanding of mathematics lessons taught in school. It will also help you to study mathematics more regularly and to start preparation for internal and external examinations as early as possible. My name is Asukwo, your extra mathematics teacher. Previously, we have treated lessons on solutions of linear equations in one variable, and we solve simple linear equations formed with any of the basic arithmetic operations like addition, subtraction, and multiplication. We also solve those involving fractions and those involving brackets. Again, we treated words problems leading to simple linear equations. In this series of our lessons, we are going to treat topics on linear equations in two variables. Linear equations in two variables. Don't forget that we are still working on the general theme, algebraic processes. Recall that an equation, of course, here we are talking about an algebraic equation, is said to be linear when the highest power of its unknown or variable is 1. Again, an equation, of course, here we are talking about an algebraic equation, is said to be linear when the highest power of its unknown or variable is 1. Often, the power 1 of the variable is not being written down at all in linear equations. For instance, 2x plus 3 is equal to 5. Again, 2x plus 3 is equal to 5 is a linear equation in one variable. The variable here is x, and the power is not written down expressly. It is only implied that the power of x in this equation is 1. Again, 2x plus 3y equals to 5 is a linear equation in two variables. This is so because there are two unknowns in the equations, and also the power of each unknown is 1. But the power is also not written down expressly. Also, the equation 2x plus 3y is equal to 5z is a linear equation in three variables. 2x plus 3y equals to 5z is a linear equation in three variables. This is because it contains three unknowns, or it contains three variables. Thus, you can form linear equations in one variable, in two variables, in three variables, in four variables, and so on, depending on the number of the physical quantities that you are dealing with as the unknowns. Note that in algebra, variables or unknowns are usually represented by letters of the alphabet. For instance, x plus 3y is equal to 7 is a linear equation in x and y. Again, x plus 3y is equal to 7 is a linear equation in x and y. The x and y are the variables and are letters of the alphabet. And any letter of the alphabet can be used to represent a variable in any linear equation. Now, the general form of a linear equation in two variables may be written as y equals to mx plus c. I want to take that again. The general form of any linear equation in two variables may be written as y equals to mx plus c, where x is the independent variable, y is the dependent variable, m is the slope of its graph, and c is the y-intercept. Again, where x is the independent variable, y is the dependent variable, m is the slope of its graph, and c is the y-intercept. As such, linear equations in two variables are straight line graphs. In solving linear equations in two variables, to have a single solution for each of the variables, we often use two different equations in the same variables whose graph must intersect. Take for instance, y is equal to 3 plus x and y plus 1 is equal to 3x. These are two different linear equations in two variables, x and y. There are various methods of solution for linear equations in two variables, such as substitution, elimination, graphing, etc. Basically, in analytical methods, we seek to write one variable in terms of the other and then solve the resulting equation for the other variable. Again, in analytical